Hello dear student, welcome to my class. So far we discussed dimensional formula of various physical quantity, and last class we already discussed 21 dimensional formula and its SI unit and CGS unit, and how to calculate dimension of various physical quantity, and how can we calculate unit from dimension and dimension from unit. Clear? Now let's start. Dimensional formula, that is 22. Already we discussed 21 dimensional formula. So now let's start dimensional formula of 22, and this is angular momentum. Angular momentum. So angular momentum, it is represented by capital L. That means it is the product of linear momentum into perpendicular distance, or you can say perpendicular linear momentum with distance. Suppose there is a particle which is moving in a circular path and its radius suppose r. Clear? And while the particle moving in circular path, then it possesses some velocity this direction, and with velocity v, then it possesses some mass of the particle, suppose m, moving circular path with velocity v, that is possess momentum p equal to m into v. Clear? And here we have to find linear momentum, and this is linear momentum p equal to mv with perpendicular distance, means this radius. So you can write here linear momentum into perpendicular distance. This distance is here perpendicular. So we can write linear momentum, that is mv into perpendicular distance is here r, and we can write the dimension of m. What is m? M is here mass velocity into r, means we have to use here the formula of distance. So the dimensional formula of mass, that is m1, and its velocity, that is L1 t minus 1 into distance is here L1. Now we can write m1 L11 L2 t minus 1 is the dimensional formula of angular momentum, and we can write it SI unit. You can write SI unit from this relation or dimension. So here m, that is mass, we can write here kg, length square, that means meter square, second minus 1, so second minus 1 is the dimensional formula of angular momentum. Clear? Or you can write CGS unit, that is gram centimeter square, second inverse is the dimensional formula of angular momentum. And next we have to find dimensional formula 23, and suppose we have to find radius or moment of inertia. Moment of inertia. So it is represented by the symbol I, and its formula, that is mass, total mass of a body, and it is represented by capital M, mass into distance square. Mass into distance square is known as moment of inertia. Suppose there is a body and it consists of number of particles. Suppose there is particle m1 mass, second particle m2, third particle m3. Now this body which rotate about, suppose this distance is r1 and this distance r2 and this distance is r3. That means this body which consists of 3 particles, 3टा particle को नहीं के body तैयारी है जी. ताले 3टा particle effect जहाँ आसिबो, we have to choose a point where total mass of the system are to be concentrated, and that point is known as center of mass. ताले center of mass कौन को आ जाए? এই 3टा particle effect जहाँ हबो, गोटे point रो effect भी सही same हबो. How can we imagine? Suppose there is 3, 4 particle 1, 2, 3, 4. if we apply 4 Newton force to individual particle, चार्टा पार्टिकल को मु 1 न्यूटन फोर्स देली ताले ये ऊपर जाउछ ना किसी डिस्टेंस एबे कोन कली चारटा आको फोर्स को 4 न्यूटन को एकाडी कर देली 1 फोर्स व्हिच इज इक्वल टू 4. नाउ वी हैव टू अप्लाई इट चारटा पार्टिकल 1 2 3 4 बे फर्स्ट पार्टिकल दे दियो से ऊपर जाई परिबो कि ना जाई परिबोनी, सेकंड पार्टिकल जाई परिबोनी, थर्ड पार्टिकल जाई परिबोनी, फोर्थ पार्टिकल जाई परिबोनी. जदि मु टोटल फोर्स गुटे पॉइंट रे कंसंट्रेट करबी देखो गुटे पॉइंट रहिला और सेही पॉइंट आबे ऊपर पळे जाउछ एंड दैट पॉइंट is known as center of mass. That means total mass of the system where concentrated that point. So similarly we have to choose a total mass point. Suppose this body is here and total mass, that means here total mass m, we can write m1 plus m2 plus m3. This is total mass and here suppose total mass this point and this point is known as center of mass and it rotates with this direction and this distance is known as r. Clear? Center of mass ro rotation ro distance को कहा जाए distance and it is denoted by r and it mass के total body ro mass ला m means सब तक mass मिसला पर जाए. So you can write here mass and dimensional formula, that is m1 into distance ro square. So you can write l square. We can write m1 L2 T0 is a dimensional formula of moment of inertia. Clear? You already know inertia. Inertia माने यार मीनिंग कौन जड़त्व बट आम ये इनर्सिया ये मोमेंट घोरीवा टाइप जो मोमेंट ऑफ इनर्सिया ता कहा जाए बुझा पड़ला ना. सो मोमेंट ऑफ इनर्सिया डायमेंशन मास इनटू डिस्टेंस स्क्वायर एंड यू कैन राइट इट SI यूनिट, that is you can write from this relation or dimension kg. Here meter square is the SI unit of moment of inertia and you can write also CGS unit. Here kg, we can write here gram and here meter square we can write, that is centimeter square. Clear? Okay. Now dimensional formula 24. Now we have to find here dimension of kinetic energy. Kinetic energy and its mathematical formula half mv square. So 1/2 into mass into velocity square. So the dimensional formula of mass, because here 1/2 is constant quantity and it don't possess any dimension, so dimension of mass we have to write here, that is m1 into velocity square and its dimension L1 t minus 1 and whole square. So m1 L2, if we multiply here then this only t minus 2. So m1 L2 t minus 2 is the dimension of kinetic energy, because all type of energy possess one unit and possess only one dimension. So here we can write the SI unit of kinetic energy, that is joule, or you can write from this relation here meter, sorry this is mass, so you can write here kg and L square, m1 L2 means meter square and second minus 2 is the SI unit of kinetic energy, or you can write CGS unit. Here if you write to joule then you can write here arc ERG and CGS unit can be write gram centimeter square second minus 2. Clear? Same way you can find the dimensional formula of potential energy. And what is potential energy? Its formula we already know, that is mgh. Suppose this is surface of earth and there is a body or there is any block and we have to choose a reference line here. Now we have to take this block through a distance. Suppose you have to take through a distance or from point A to point B through a distance h or height h. Clear? So at this point when we displace the particle or when we displace the body from reference line to h height, we have to do some external work against gravity. What is gravity? Because gravity always downward direction and the value of gravity that is mg, but body displays which is upward direction. ग्राविटी तल को पड़े भी ग्राविटी अगेंस्ट आम बॉडी को ऊपर को नेले तो आमर किसी वर्क है आमर किसी वर्क लॉस है एंड यू ऑलरेडी नो एनर्जी नाइदर बी क्रिएटेड नॉर बी डिस्ट्रॉयड बट इट कैन ट्रांसफॉर्म ताले आम जो वर्क कले से वर्क गला कुआडे दिस वर्क इज स्टोर इन द पोटेंशियल एनर्जी इनसाइड द बॉडी बुझेला सो एच हाइट रे पोटेंशियल एनर्जी केते दैट इज एम जी एच आम जी अमाउंट वर्क कले से पोटेंशियल एनर्जी रहीगला और फर्मूला है एम जी एच क्लियर सो दैट इज नोन एज मास ऑफ द बॉडी जी मीन्स एक्सीलरेशन ड्यू टू ग्रेविटी एंड इनटू एच मीन्स हियर हाइट दिस इज हाइट सो हियर मास and we know the dimension of mass we can write that is m1 acceleration due to gravity and we can write the dimension of acceleration L1 t minus 2 into height it is measured in terms of distance so L1 so its dimension m1 L2 t minus 2 because potential energy also energy so in nature same physical quantity possess same type of dimension and same type of unit so can write your SI unit that is joule and CGS unit you can write that is ERG or you can write the unit from this relation then this unit will be like this clear so these are the dimensional formula of kinetic energy and potential energy now we have to find the dimensional formula of wavelength. So what is wavelength? 25. Wavelength actually is a distance. Suppose there is a wave and it is represented by lambda wavelength. Suppose there is a wave means taranga. So this is the propagation of wave propagation means गोटे wave एमती आगो को आगो चलछि समुद्र ठाउ केमि चले एमती आगो चलले नै this is wave and this is known as crest that means here the water molecule or any molecule or any particle which vibrate with maximum amplitude maximum distance ए मेन पोजीशन रो maximum distance गिटार बजेबा एमती फास्ट पार्टिकल को स्ट्रिंग को छाड़ दवा ऑसिलेशन होबो ना नै से ऑसिलेशन रो wave clear and this point is known as crest and this is maximum displacement but downward direction and this point is known as trough clear and या कौन कहा जाए crest को शिखर and कौन कहा जाए गह्वर clear the distance between and this wave traveling this medium in such a way this direction clear and here is crest and this point is crest the distance between crest to crest and this is trough and this is trough the distance between trough to trough is known as wavelength and this is lambda is called wavelength simply you can say that it is the length of the wave from crest to crest or trough to trough. So its dimensional formula you can write for length m0 l1 and t0 is dimensional formula of wavelength and it is measured in SI unit that is meter and CGS unit that is centimeter or we simply write that is cm clear next we can write 26 number of dimension that is known as Planck constant. Planck's constant. So now we have to find dimension of Planck constant. It is represented by h according to the name of the scientist. So Planck constant we have a relation that is E equal to h nu. This is famous relation. E means energy. Suppose there is a sun and which produce light in all the direction towards the surrounding. Clear? And this light consists one type of energy, and that energy which is known E equal to h nu, and this energy is known as here the sun. Suppose this is sun, it consists energy, and that energy is known as packet of energy or photon energy. You will study your higher class. So this h is here. This h is known as Planck's constant, and we can write here Planck's constant h equal to E by nu. So here nu means frequency. We will discuss here. This is energy. So energy divided by frequency. Now first we have to show what is frequency. That is frequency. First we have to know 1 by time period. 1 by time period is known as frequency. Suppose there is a circle of radius r. If we give 1 second, then you have to move along the circuit in this way. तुमको गोटे सेकेंड समय दिया तुम ये सर्किल स्टार्ट हेलो केते थर गोटे सेकेंड रे कंप्लीट करि परिबो. दैट इज नोन एज फ्रीक्वेंसी. नंबर ऑफ रिवोल्यूशन पर टाइम पीरियड. गोटे सेकेंड रे तुम केते थर दौड़िलो. धर गोटे सेकेंड रे तुम थरे मूव कल रिवोल्यूशन 1, देन फ्रीक्वेंसी इज 1. धर गोटे सेकेंड रे रिवोल्यूशन 2 थर हैला, फ्रीक्वेंसी इज 2. धर गोटे सेकेंड रे 3 थर रिवोल्यूशन हैला, frequency is 3. Clear? So this is frequency means 1 by time period, and it is denoted by nu. या कौन कहा जाए nu. एक pronunciation तुम एक पढ़ी पारिबो nu. Nu means frequency, or you can write here small f. Clear? That is frequency, and frequency if small f or nu we can write 1 by time period. So 1 by time t, and its dimensional formula you can write, that is 1 by t. And here 1 by t1, and t minus 1 is the dimensional formula of frequency, or you can say m0, l0 and t minus 1. So in frequency there is only one term, that is time, and its dimension t minus 1. So if we want to write its SI unit, we can write second minus 1, or it is known as Hertz. HERTZ. Clear? That is known as frequency. तुम रेडियो सुनते हो सब. So रेडियो का फ्रीक्वेंसी है 91 and 290 so 99 hertz, 99 hertz frequency, or 2000 frequency, or 200 frequency, like this. This is the frequency, and its unit, that is hertz, or you can say second inverse, and CGS also CGS unit also same. So we have to use your energy per frequency, and this is frequency, and dimensional formula t minus 1. m1 l2 t minus 2 divided by here t minus 1. Now solve this relation. Here that is m1, here l2, and t minus, this is minus 1. If you take to numerator, then here plus 2 minus 1, 1 minus cancel, so you can write m1 l minus 2, m1 l2 t minus 1 is the dimensional formula of Planck constant. It is represented by h. Clear? And if you want to write SI unit of Planck constant h, the energy by frequency, so you can write joule per second inverse. Clear? Or you can write joule second is the SI unit, and you can write it CGS unit. CGS unit I am writing here. So CGS unit of Planck constant, that is joule second, or you can write arc second, ERG, arc second is also the CGS unit of Planck constant. Next we will start another derived physical quantity, that is known as gas constant. So dimension number 28, gas constant, and this gas constant, it is dependent by capital R, and you already know a relation in chemistry, that is PV, which is equal to nRT. So what is P? P is here pressure, V means volume, N means number of mole. Here n, small n, which is represented, that is number of mole. Clear? And what is R? R is here gas constant. What is T? T is here temperature. So you can write gas constant R equal to, that is PV divided by N into T. And here N is mole. That means here pressure, you can write pressure into V. It is not velocity, it is volume. Pressure into volume divided by mole into temperature. So its dimension you can write pressure. Its dimension pressure equal to that is force per unit area. So you can write the dimensional formula of pressure M1L minus 1 T minus 2, force per unit area, into volume L3 divided by mole, and we have to measure, we already know the dimension of mole, that is MOL, small mol, and temperature, its dimensional formula, that is K. Now if you solve this relation, we get M1 L minus 1, here L3, then L2, M1 L2 T minus 2, mole minus 1, and here Kelvin minus 1 is the dimensional formula of gas constant R. Clear? If you want to write SI unit of gas constant R, then here you can write the unit from the dimension. Here M1 means kg, meter square, here time, second minus 2, here mole minus 1, and here Kelvin minus 1. Clear? These are the SI unit, this is SI unit of gas constant. If you want to write CGS unit, then gram, centimeter square, second minus 2, and here mole inverse and Kelvin inverse. Clear? So this is the dimensional formula of gas constant. Now we have to start the dimension of another physical quantity. Dimensional formula 29. So here we have to find, that is velocity gradient, or first we have to find here rate of flow, dimension of rate of flow. Now let's start rate of flow, and its formula, physical formula, that is volume divided by time. So suppose there is a pipe and there is a bucket here, and the water now flowing through the vessels here, suppose, and we have to find the dimensional formula rate of flow. How much liquid flow or how much liquid contain inside the container for 1 second. Suppose मैं गोटे सेकेंड टाइम देली, गोटे सेकेंड टाइम रे एडी लिक्विड अच्छी सपोज 1 लीटर, और वी कैन से सपोज इट्स वॉल्यूम 5 मीटर क्यूब. Clear? And again if we take 2 seconds, then suppose here 8 meter cube. So we have to find here the dimensional formula rate of flow. Rate of flow means how the speed of liquid inside a tube or inside a pipe. Now we have to find here this formula volume. How much volume of liquid contain in the container in a particular time interval. हमें गोटे सेकेंड देले 5 मीटर क्यूब पानी स्टोर होला, 2 सेकेंड देवा सपोज 8 मीटर पानी की स्टोर है सो वी हैव टू फाइंड रेट केते रेट रे वाटर फ्लो होची तो रेट ऑफ फ्लो ऑफ वाटर ए पाइप भीतर जो पानी लिक्विड आसी केते रेट रे लिक्विड आसी दैट इज नोन एज रेट ऑफ फ्लो क्लियर सो इट्स डायमेंशनल फॉर्मूला वी कैन राइट वॉल्यूम एंड डायमेंशन दैट इज L3 डिवाइडेड बाय T1 m0 L3 T minus 1 is the dimensional formula of rate of flow. Or if you want to write SI unit, meter cube divided by second, and CGS unit, centimeter cube per second is rate of flow. Next, velocity gradient. Velocity gradient. So you have to remember this term. Velocity gradient means velocity per distance. So here velocity divided by distance. That means if we increase distance, then at that time the velocity increase or decrease, it depends on velocity gradient. Clear? That is known as velocity by distance. And here we have to write the dimension velocity. So m0 L1 T minus 1 is dimensional formula of velocity divided by L1. And here L1 cancel the remaining part, that is m0 L0 T minus 1 is dimensional formula of velocity gradient. Clear? Velocity L1 T minus 1, distance L1 cancel, and remaining part. So now if you want to write the SI system or a unit of SI system of velocity gradient, velocity and here meter per second divided by distance is here meter, so we can write meter per second into 1 by meter, meter cancel, we can write here second inverse or 1 by second, which is second minus 1 or second inverse. But you can find the unit of this velocity gradient from this dimensional equation, because mass 0, length 0, so only time contains, so here second minus 1 is dimensional formula SI dimension, or you can write CGS dimension also same, it is second minus 1. So this is the dimensional formula of velocity gradient. Same way we have to find the important dimensional formula, and that is known as coefficient of viscosity. Or before that, if you want to find the dimension of other physical quantity like velocity gradient, and you can find dimension 31 pressure gradient. Pressure gradient. So what is pressure gradient? Like velocity gradient means velocity divided by distance. Same way you can write here pressure divided by distance is known as pressure distance. We already discussed the dimensional formula of pressure. M1 L minus 1 is here. M1 L minus 1 T minus 2 divided by T1, and dimensional formula M1 L minus 1, and here that is T minus 3, because here T1, and if we take to the numerator, then this part will be minus 1 minus 3. So M1 L minus 1 and T minus T minus 3 is dimensional formula of pressure gradient. If we want to write SI unit, then we can write here M1, so kg, meter minus 1 and second minus 3. And if you want to write CGS unit, that is gram, centimeter minus 1 and second minus 3 is dimensional formula of pressure gradient. Same way you can find the dimensional formula of coefficient of viscosity. It is dependent by eta. Now we have to find the dimension of coefficient of viscosity. So you already know the meaning of friction. So what is friction? Friction means it is oppositional force comes into play between two surfaces of contact. Suppose there is a body, or if you want to take any example, suppose this is duster, and if we place on the palm, then this is contact surface. if this duster which moving this direction, so its velocity this direction, and there is a oppositional force develop in between two contact surface of palm and duster, and that force which always oppose the motion. जदि आम डस्टर रखिले दिस इज द डायरेक्शन ऑफ वेलोसिटी ऑफ डस्टर दिस डायरेक्शन देन ए कांटेक्ट सरफेस रे जेपर्यंत कांटेक्ट न होई से पर्यंत फ्रिक्शन नाही जेतरा कांटेक्ट हैला कांटेक्ट रो अपोजिट डायरेक्शन दैट मींस इट इज ऑलवेज अपोजिट टू द डायरेक्शन ऑफ वेलोसिटी इन द उल्टा पटे एंड इट इज ऑलवेज ट्राई टू डिक्रीज द वेलोसिटी ऑफ द बॉडी दैट इज नोन एज फ्रिक्शन एंड फ्रिक्शन ऑलवेज एक्ट ऑन टू सरफेस ऑफ कांटेक्ट and that two surface should be just like may not be liquid except liquid or you can say this is solid surface dita solid surface re jetebele oppositional force ase ta kon kha jaye taku friction kha jaye clear okay but in liquid case there is a different type of liquid layer suppose this is topmost or upper layer this is ground layer these are the layer of liquid जो कैनाल में पानी जाऊँगी सब स्तर तार अच्छी फर्स्ट लेयर सेकेंड लेयर थर्ड लेयर फोर्थ लेयर कौ लेयर लिक्विड स्पीडा अधिका टॉप मोस्ट लेयर लिक्विड स्पीडा अधिका थाए बट बॉटम मोस्ट लेयर रे पानी स्पीडा कम थी क्लियर सो इन दिस केस we have to derive a relation coefficient of viscosity suppose viscosity रा मीनिंग है देखो there is different layer and different layer भीतर फ्रिक्शन होउछ ना ये फर्स्ट लेयर सेकेंड लेयर एंड ए लेयर जति हम ऊपर को जीवा पानी स्पीडा बढ़ी चलछि ना कमी चलछि while x increase then velocity of liquid layer this is the relation of velocity of liquid also increase distance बढ़िले velocity बढ़ुछि तले हम दीटा लेयर लेने layer 1 and this is layer 2 and here suppose second layer which moving with velocity here v1 or v suppose v then this two layer contact with each other and this layer try to increase the velocity in this direction but first layer does not try to move this direction and it produce a repulsive force and it produce a force this direction which is opposite to this velocity रो opposite रे जो force आसे से force को friction कहा जाए but liquid केस ताको मैं friction कहबा नहीं but in case of liquid we say that this force is known as viscous force or viscous drag viscous force कहि परिबा or viscous drag कहि परिबा clear and this force is oppositional force with velocity clear and this viscous force which depends on area of contact केते एरिया रे पानी अच्छी और केते एरिया लिक्विड कांटेक्ट है कि अच्छी ता ऊपर डिपेंड करे f राइटली प्रोपोर्शनल टू a लिख परिबा एंड देन सेकेंड fv इज डायरेक्टली प्रोपोर्शनल टू dv by dx यार मीनिंग वेलोसिटी ग्रेडियंट वेलोसिटी बाय डिस्टेंस जति जति हम डिस्टेंस ऊपर को बढ़े चलवा से रेस्पेक्ट पानी स्पीडटा बढ़ी चलो ग्राउंड लेवल सीधा 0 थी ये v1 ये v2 ये v3 देन v3 ग्रेटर देन v2 इट इज v1 डिस्टेंस जति बढ़ी चलला वाटर स्पीड और लिक्विड स्पीड से बढ़ी चलला एंड दिस फोर्स डिपेंड्स ऑन दिस टू फैक्टर सो if you compare these two factor or combining two factor we can write here fv equal to fv directly proportional to a dv by dx and यदि proportional हम उठे दबा there is a constant so fv equal to eta this proportionality constant is here eta and eta a dv by dx and eta equal to that is fv divided by a into this is dx divided by dv and this eta is known as coefficient of viscosity clear so coefficient of viscosity depends on this factor and we can write dimension f means here force and dimensional formula m1 l1 t minus 2 into distance is here l1 divided by area L2 and here the velocity L1 t minus 1 if you solve this relation m1 So you can write here M1, L1, L1, L2, L1, or you can L1, L1, L2, L2, cancel the remaining part L1, and here you can write that is L minus 1, and again here T minus 1, if we take to the numerator then minus 2 plus 1 which is equal to minus 1, so T minus 1. You have to remember this formula, this is important formula, clear? So you have to remember this formula, dimensional formula of coefficient of viscosity M1, L minus 1, T minus 1, and its SI unit, you can write here SI unit of coefficient of viscosity M1, that is here kg, L minus 1, meter minus 1, and time, that is second minus 1. In this way you can calculate CGS unit, gram, centimeter, second minus 1, clear? So this is the dimensional formula of coefficient of viscosity, and this is dimensional formula number 31. Now let's start another derived physical quantity, and just you have to remember the physical formula and how to derive a dimension. So first thing is that you have to remember the physical formula of derived physical quantity, then it is easy to calculate dimensional formula and its SI and CGS unit, clear? So now next start 32, refractive index. Refractive index, you already know it is represented by mu, and refractive index mu means suppose there is a medium separated by two medium, medium number 1 and medium 2, here air medium and this is denser medium. When light traveling from air medium to denser medium, then it bend towards normal, and this angle is known as I and this angle is known as R. तुमको स्नेल्स लॉ जाना है, स्नेल्स का नियम, अकॉर्डिंग टू स्नेल्स लॉ यू कैन राइट रिफ्रैक्टिव इंडेक्स म्यू इक्वल टू sin I by sin R. That was a refractive index, and this refractive index is constant for this medium, clear? So we have to find the dimensional formula of refractive index, and it is represented by velocity of light in free space or vacuum, velocity of light in vacuum divided by velocity of light in the medium. यदि ये एयर मीडियम हुए एट लाइट फास्ट लगता है 3 × 10⁸ मीटर पर सेकेंड, बट ये डेंसर मीडियम अदर देन एयर मीडियम, बट ए मीडियम वेलोसिटी केते सपोज v, क्लियर? सो वी हैव टू यूज दिस रिलेशन हियर, स्पीड ऑफ लाइट इन वैक्यूम, वैक्यूम रे जहाँ स्पीडटा थिबो वैक्यूम स्पीड केते c अछि ना नहीं, सो कैन राइट हियर c डिवाइडेड बाय c मींस 3 × 10⁸ मीटर पर सेकेंड, एंड अदर मीडियम other than air medium and velocity v, so you can write here v, but c is speed, v is also speed, theta ka velocity, so dimension we can write here m0 l0 t0. This is dimensionless physical quantity. So refractive index mu is a dimensionless and unitless physical quantity, clear? Okay, now sorry, it's dimensionless and unitless physical quantity. Now let's start another one physical quantity. Now come to the heat part, thermodynamics part or heat. So first we have to find dimensional formula of specific heat, or you first find the dimension of heat. Actually heat is the form of energy, so we can write heat is equal to energy, and a dimensional formula m1l2 t minus 2, and you can use the unit SI unit, that is joule, and its CGS unit, that is erg, clear? And if you want to find dimension of specific heat, specific heat. So what is specific heat? Here heat is directly proportional to mass and temperature difference. Suppose there is a bucket or any substance, suppose water nelly, and mass kitne is 1 gram of water. Now give some amount of heat to raise its temperature of 1 degree Celsius. गोटे ग्राम पानी को गरम करिया पाई और गोटे ग्राम पानी को 1 डिग्री सेल्सियस राइज करिया पाई जतिके अमाउंट रो हीट दरकार हुए से हीट टा कौन कहा जाए? दैट इज नोन एज स्पेसिफिक हीट. एंड हियर वी कैन राइट हीट इज डायरेक्टली प्रोपोर्शनल टू m मीन्स केते ग्राम, डेल्टा t माने केते टेम्परेचर चेंज हैला. सो वी कैन राइट हियर दैट इज हीट इज proportionality constant, sorry, proportional मतलब constant ऐसे, and this constant is represented C m delta t, and C is here specific heat capacity, and this formula we can write heat divided by m into delta t. Clear? And the dimensional formula of heat you already know, m1L2T minus 2 divided by m. M is here 1 gram. So we can write here for SI system we can write that is kg. Sorry, we have to write dimension here. So it's m1 into temperature. Temperature is its unit, that is Kelvin. So we can write K1. So its dimensional formula we can write here. M1 cancel. L2, or we can write m0 L2 T minus 2 K minus 1 is the dimensional formula of specific heat C, and its SI unit you can write from this relation m0 L2 means meter square, and T minus 2 means second minus 2, and Kelvin minus 1. This is SI unit. Clear? Okay, or you can write from this relation heat by, or you can write heat means its unit joule per mass, which is equal to kg, and here temperature, that is Kelvin. This is another unit of SI, unit of specific heat, and you can write CGS unit from this relation, that is org divided by kg into gram and Kelvin. This is CGS unit, and this is MKS unit of specific heat. Clear? Now let's start another physical quantity of heat, that is known as latent heat. So what is latent heat? जो हीट हमको देखा जाए बट से किसी काम करे से हीट को latent heat कहा जाए. Then dimension number 35. Suppose there is a ice which is equal to 1 gram ice, and its temperature suppose 0 degree Celsius. Now provide heat. बर्तमान हम ताको heat देले. Clear? So हमें heat देला परे 1 gram water, sorry, ice to it convert into water. हमें temperature देले कौन है चलिबो ना ice टा water को convert है जिवो. बर्तमान it's now this ice converted to liquid and state change. ये ice state रे थिला बर्तमान लिक्विड स्टेट को पळेला, आ लिक्विड स्टेट दैट इज नोन एज वाटर. बट एबे भी कोन देखाला ना टेम्परेचर केते अछि हियर 0 डिग्री सेल्सियस. ना हियर टेम्परेचर आल्सो 0 डिग्री सेल्सियस, बट हियर द इनिशियल कंडीशन ऑफ दिस सब्सटेंस इज आइस, बट नाउ दिस सब्सटेंस इज वाटर. ताले हम जतिके अमाउंट रो हीट देले से हीट गला कोडे से हीटा कोना कोडी लुचिकी रहि जाय छै भितरे, एंड दैट हीट इज नोन एज latent heat. And if this latent heat help to the substance to change its state, ice to liquid or liquid to ice को change करिवारे जो हीट जो लुचिकी हीट ता थाए ताक हीट को कहा जाए latent heat. से देखा जाए नहीं और से भीतर भीतर कौन चेंज करे? स्टेट चेंज कर दिए. क्लियर? एंड दिस latent heat, its formula heat divided by mass. Clear? And you already know dimension of heat m1 L2 T minus 2 divided by mass m1, mass cancel, and the dimensional formula of latent heat, that is m0 L2 T minus 2, and you can write SI unit here, heat, joule per kg, or you can write CGS unit or ERG per gram. This is the unit of latent heat. Clear? Now let's start. Thermal conductivity. This is important phenomena in physics or heat. What is thermal conductivity? Suppose there is a substance, or there is a container, and here the temperature of the container Q1, and this container which connect through a conductor or any substance here. Now this conductor which connected across another substance, another source or another reservoir, suppose theta 2 and theta 1. What is theta 2 and theta 1? Here its temperature Q1, theta 1, and here temperature is theta 2. There is two substance, theta 1 and this is known as theta 2. Clear? And here high temperature, here Q1 is greater than Q2. Suppose here temperature 30 degrees Celsius and here temperature 10 degree Celsius. Now you know heat always flow from higher temperature to lower temperature. This is the property. So this is the direction of flow of heat, and this heat flow through the conductor or through this substance, it depends on its thermal conductivity. This thermal conductivity आम ये यूज करवा गोटे आम यूज करवा धर आयरन आम नेबा आम ओड नेबा ताले कोडी थर्मल कंडक्टिविटी अधिका थिबो आम से केसटा डिस्कस करिया कोडी जल्दी हीटा फ्लो होई पारे आ कोडी हीटा धीरे धीरे फ्लो हबो ये का पर डिपेंड करे इट डिपेंड्स ऑन द थर्मल कंडक्टिविटी क्लियर ओके तुम इमेजिन कर पारिबो समर सीजन रे जो चाल घर समस्त जानी थो जो चाल नड़ा जो तैयारी होता है से घर बहुत ठंडा लगे आम जो देखा सीमेंट रे तैयारी घर हो जोटा आम कंक्रीट तैयारी घर से अधिक गरम लगे कौन पाई ड्यू टू थर्मल कंडक्टिविटी तुम शीत दिन जैकेट पिंध सब स्वेटर पिंध कौन पाई ड्यू टू थर्मल कंडक्टिविटी सो विल डिस्कस क्लियरली व्हाइल व्हेन वी आर डील्स विथ द थर्मोडायनामिक चैप्टर नाउ we have to just study about, or we have to just find the dimension of thermal conductivity here. Clear? And this heat flow, and this heat which flowing through this material is depends on the following factor. It depends on or directly proportional to area of cross section. Area of cross section means it rod like जाना नहीं जब it substance नहीं हो ये substance टा कितने area अच्छी एतिक बड़ एरिया ऑफ क्वेश्चन अच्छी ना एरिया ऑफ क्वेश्चन ना अधिक एतिक बड़ अच्छी ना आउ किसी नहीं पारे एरिया ऑफ क्वेश्चन एतिक बड़ अच्छी बुझा पड़छ ना दिस इज नोन एज एरिया ऑफ क्रॉस सेक्शन सो डायरेक्टली प्रोपोर्शनल टू ए एंड देन टेम्परेचर डिफरेंस थीटा 1 माइनस थीटा 2 ये टेम्परेचर डिफरेंस केते अच्छी 30 डिग्री 10 डिग्री अच्छी ना 30 डिग्री इहर 0 डिग्री अच्छी कौन टेम्परेचर डिफरेंस अच्छी तापर डिपेंड करे हीट फ्लो एंड सेकंड थिंग ये केते टाइम जाए फ्लो हैला 10 मिनट फ्लो है ना 5 मिनट फ्लो है ना गोटे सेकेंड फ्लो है हीट डिपेंड्स ऑन टाइम एंड नेक्स्ट थिंग सपोज द डिस्टेंस बिटवीन और द डिस्टेंस ऑफ दिस सब्सटेंस इज डी द डिस्टेंस टा डी हुए इट इज इनवर्सली प्रोपोर्शनल मीन्स आम ए डिस्टेंस टा डी सपोज मन कर 1 मीटर अच्छी ये एंड जहाँ हिट पाइबा जदि यार लेंथ को आम 4 मीटर लेंथ इनक्रीज करदेवा यही एंड से सेम हिट थी ना सेम हिट से नथिबो क्लियर से डिपेंड सो इफ डिस्टेंस इंक्रीज देन हीट फ्लोटा कौन हो डिक्रीज इफ यू कंबाइन ऑल दिस रिलेशन वी कैन राइट हीट डायरेक्टली प्रोपोर्शनल टू ए थीटा 1 minus theta 2 means temperature difference into time divided by distance d and this is proportionality and we can write here heat equal to one proportionality constant that is k a k could be called thermal conductivity and k which is equal to a into theta 1 minus theta 2 into T by D, and you can write here K equal to heat into distance, heat into distance divided by heat into distance divided by A into temperature difference theta 1 minus theta 2 and here time T. Clear? So you can write the dimension of this thermal conductivity K, heat. Dimensional formula kona? M1 L2 T minus 2 divided by, here distance. So you can write L1 is here, L1 divided by area and dimension L2 into theta 1 theta 2. ये theta 1 theta 1 dimension क्या dimension? ये dimension है temperature, and you can write the dimension of temperature K1. Next here time dimension T1. Clear? If you solve this relation, then we get the dimension of K, which is equal to here M1 L2, here L2 1 L2 1 L2 cancel, then the remaining part here L1 M1 L1 and here T minus 2 another one T1, so T minus 3 and here Kelvin minus 1, K minus 1 is a dimensional formula of thermal conductivity. And here any different type of exam it may ask write the dimensional formula of thermal conductivity or write SI unit. So its SI unit you can write here, that is heat distance. You can write here joule, joule into meter divided by area meter square, temperature here Kelvin, time is here second, or 1 meter cancel, so you can write joule per here meter, Kelvin and second. Clear? So this is SI unit of thermal conductivity, or you can write CGS unit of conductivity. Joule you can write arc, ERG here meter, centimeter and Kelvin, and this is CGS and this is MKS unit of thermal conductivity. Clear? So these are the just 1, 2 or 3 derived physical quantity and their dimension regarding heat chapter. Clear? Or if we want to find another dimension also, dimension number 35 or 36, you can write, you already know according to Ohm's law V equal to IR. Or if you want to find the dimension of resistance, or if you want to find first dimension of charge, and charge is denoted by its unit is coulomb. So the dimension of charge you have to remember, that is we already know. First we have to find dimension of current, it is easy. So dimension of current, which is equal to here current is I, and we already know the dimensional formula of electric current, which is basic and fundamental quantity, and its dimension A1. So you can write that is M0 L0 T0. A1 is dimensional formula of electric current and its SI unit, that is ampere. Clear? And its CGS unit is known as state ampere. So CGS unit state ampere. And now we have to find dimensional formula of charge. So what is the dimension? What is the mathematical formula of electric current? I equal to total amount of charge flowing per unit time. Total amount of charge divided by time equal to, we get electric current. And here charge, this is charge. Charge divided by time, which is equal to electric current. Clear? So charge equal to current or electric current into time, and its dimension A1 and time is here T1. So dimensional formula M0 L0 T1 A1, dimensional formula of charge, and its SI unit, you can remember this SI unit known as coulomb. represented by C. Clear? And CGS unit state coulomb. Now find the dimensional formula of resistance. Clear? Or you have a relation, that is electric potential. Electric potential, and this potential represented by V equal to W by Q. Clear? And केते अमाउंट रो वर्क डन कराला Q चार्ज उपरे से कांस्टेंट रही जाए जतिके अमाउंट रो वर्क डन कराला जमी थिला मेकानिक्स रे जतिके अमाउंट रो में वर्क डन कले सेटा पोटेंशियल एनर्जी स्टोर रही जाउची आ से पोटेंशियल कोन कहा जाए मेकानिकल पोटेंशियल एनर्जी. बट हियर जतिके अमाउंट रो में वर्क कले या ऊपर ना चार्ज उपरे सेटा कांस्टेंट रही जाए पोटेंशियल एनर्जी, and this potential energy is known as electric potential energy. And here V equal to W by Q, and electric potential is V equal to W means work. Work by Q means here it is charge, and work dimensional formula M1 L2 T minus 2 by charge. Charge equal to AT. So you can write here A1 T1, and its dimensional formula M1 L2 T minus 3. And A minus 1 is dimensional formula of potential. Clear? And its SI unit you can write work by charge. Work by charge equal to joule per second, sorry, joule per coulomb is dimensional formula of electric potential, or simply you can say volt. Clear? Okay. So you can write another dimensional formula, that is resistance. Resistance which is denoted by R according to Ohm's law. तुम समझते हो Ohm's law जाने जाओ V equal to IR. Potential is directly proportional to resistance, and one constant apply here. This constant is known as resistance, opposition, प्रतिरोध, and this प्रतिरोध or resistance can be find R equal to V by I. V टा कौन potential, a dimension कहते हैं dimension M1 L2 T minus 3, M1 L2 T minus 3. Here A minus 1 divided by, this is A minus 1 divided by I the current, that is A1. So dimensional formula you can write R equal to M1 L2 T minus 3 and A minus 2 is dimensional formula of resistance, and its SI unit, that is ohm, OHM, or symbol you can write, that is ohm. Clear? Or CGS unit, statom, etc. You will study in your second year chapter. So these are the dimension and dimensional formula of various physical quantity regarding electrostatic or charge properties. Now let's start another dimensional formula, that is capacitance. And you already know Q equal to CV, or Q directly proportional to V. There is a relation in capacitor. Charge is directly proportional to potential. आम जति potential बढ़े बढ़े चलिबा सेति charge store टा बढ़े बढ़े चलिबो बुझिला. That is known as capacitor is the storage device, and it stores charge for temporary. किछ समय ପାଇଁ charge store कर रखे ताको आजा capacity or capacitor, and it is represented by symbol C. So Q equal to CV, or Q directly proportional to V, or Q equal to one constant C V लिखा जाए. Clear? And C is here, capacitance can be write Q by V, charge by potential. Charge by potential means this is electric potential. Electric potential, and charge dimension A1 T1. Electric potential dimension is here M1 L2 T minus 3, M1 L2 T minus 3, A minus 1. Now let's start. Here M minus 1, L2, L minus 2, T3 means T4. T4 is here, a T minus 3, T4, and A1, A2. This is the dimensional formula of capacitor, and you can write its SI unit. You can find the unit from this relation or dimension, or simply you have to remember the unit or SI unit of capacitor, that is known as farad. Clear? So these are the dimension of different physical quantity. So we discuss 40 physical quantity and their dimension and dimensional formula. So we discussed 40 dimension and their dimensional formula. Clear? Now this 40 dimension and dimensional formula divided into 4 category, that is different type of variable and constant. So first one, dimensional variable, and second one here dimensional constant, and third one dimensionless variable, and fourth one dimensionless constant. So what is dimensional variable? It is the type of physical quantity which possess both dimension and it changes its value. That means this type of physical quantity have no fixed value. Example, that is force, velocity, acceleration. These are the physical quantity under dimensional variable. A physical quantity रो dimension अच्छी आर value fix नहीं. Suppose मु कहबी एबे force रो dimension अच्छी ना नहीं, m1 l1 t minus 2 dimension अच्छी. Suppose यार value वर्तमान 10 न्यूटन. ए 10 न्यूटन फोर्स गोटे बॉडी ऊपर पकाला. सपोज देयर इज ए बॉडी अप्लाइड 10 न्यूटन फोर्स. ये एवरी टाइम सब बेले कौन 10 न्यूटन फोर्स पड़ती हो, यार वैल्यू केतला चेंज हुए 5 न्यूटन 0 2 3 4 एक्सेट्रा. सो दिस आर द क्वांटिटी व्हिच पोजेस डायमेंशन एंड इट चेंज इट्स वैल्यू. यार वैल्यू कभी फिक्स नहीं. सही प्रकार क्वांटिटी कौन कहा जाए? डायमेंशनल वेरिएबल. फोर्स, वेलोसिटी, एक्सेलरेशन, मोमेंटम, मोमेंट ऑफ इनर्शिया, so on. Clear? Similarly, dimensional constant. एमिति physical quantity को जर dimension थिबा but value remain constant. Possess dimension, have dimension but fixed value. Like speed of light, because 3 into 10 to the power 8 meter per second, this value remain constant but have dimension, and dimension that is m0 l1 t minus 1. Similarly, you can say Planck constant, then gas constant, gravitational constant G, capital G, its value fixed but have dimension. This type of physical quantity which under the dimensional constant. Next, dimensionless variable. एमिति किसी physical quantity अच्छी जो physical quantity रो dimension नहीं but value change हो जाए. That means no dimension but its value change, but it changes its value. That means its value not fixed. एमानकर value fixed नुहे. Say type of physical quantity is under the condition of dimensionless variable. Example, strain, angle. Dimensionless variable, strain, or you can write refractive index, angle or angular displacement, etc. These are the example of dimensionless variable. एमानकर dimension नहीं but value change हो जाए. refractive index को मीडियम पाई केते, वाटर मीडियम पाई के थिबो 1.33, ग्लास मीडियम पाई 1.5. क्लियर? सो the refractive index changes its value but its dimension 0. Dimension, there is no dimensional quantity m0, l0, t0. So next, dimensionless constant. No dimension and dimensionless constant and fixed value. These are the quantity, no dimension and always fixed value. Suppose if you want to write real number or natural number, all real number, suppose 1, 2, 3, 4, so on. This value 1 always constant, value 2 always constant, 3, 4, these are constant quantity. And next you can write like trigonometric function also, or exponential function e to the power x format. This is also constant quantity. Or you can take another constant quantity or pi, its value always 22/7. These are the dimensionless constant, its value always fixed and it has no dimension. Dimension नहीं कि मानकर value सब वाले fixed है, सही type ର quantity कौन कहा जाए? Dimensionless constant. Clear? Dimensionless constant. Value fixed थिबा but dimension न थिबा. Clear? So these are all about different type of dimension and dimensional formula. Clear? Next class we will start here uses of dimension. Thank you all.